Hi, my name is Chloe. I'm a Math 95 student at MiraCosta College, and today I'm going to be doing a retirement problem. So the first step, the problem is our average monthly cost of living in New York, excluding rent or mortgage payments, is $4,100. According to the U.S. Bureau of Labor Statistics, the average inflation rate is 2.0% annually. According to the Social Security Administration, the average American will live 20 years into their retirement. So the first step that we do, the answer to the first question is, what will our future monthly cost of living in 40 years from now be? So we use the future value equation to discover that. So it's FV equals P1 plus I to N2. And we're going to use the numbers from the problem that I just read. So our future value, which is our future cost of living, equals 4,100, which is the current cost of living, times the quantity 1 plus 0.02, which is the annual inflation rate, 0.02 over 1, which is annual, so it's over 1, to 40, because that's how many years into the future we're looking at. And since it's annual, it's just that. So that is our future value, then is $9,052.96, but we're going to round up to 97 cents because we want to make sure that we have enough for our future value when the time comes for that. So once we have our future value, I'm going to stick it over here. Future value, which is our future cost of living, $9,052.97. Then we can move on to the second part of our problem, which is going to be how much do we need to have in our retirement account to be paid out equal monthly amounts in the amount of the amount in the first part that we did of the future value each month for 20 years if the account earns 5% annual interest compounded monthly. So we're going to use this equation to solve that one. So it's times I and T is equal to payment 1 plus I and T minus 1 over I. So the way that we're going to do this one is plugging in our numbers. It's going to be P times 1 plus 0.05 over 12 because it's 5% annual compounded interest over 12 for 20 years every month equals our future value back over here, 9,052.97 times quantity 1 plus the I again for the same amount of time, minus 1 all over the I again, which is 0.05 over 12. So this part is right here, is 2.7126402085, and then you include the P from here, equals, and let me do this with a calculator really quick, 9,052.97 times the quantity 1,000. 7 times the quantity 1 plus 105 over 1, that's our I, to 20 times 12 minus 1 over 205 over 12 again. So then that's going to be 372107 5.47. Let me move this really quick. And then our next step is going to be dividing. Our next step is going to be dividing. So we're going to divide this 2.7126400285 from the other number that we have here, 64028. And that's going to give us so the 3721075.47 divided by 2.7126400285. That is 1371754.114, and that number is our how much we need to have in our retirement account to be paid out equally, to get equal monthly payments paid out to us during the 20 years that we're retired. So we need to figure out how we're going to save this in 40 years. So let's save that up here. This is our P, how much we need to have. And then again, we're going to have that be rounded a little bit because we want to make sure that we're going to have enough in our retirement account for us to fulfill the needs that we need for our future value based on the equation we did first that determined how much we're going to need to live based on the future value. So the next part that we're going to do is how much do we need to invest or save each month at 7% annual interest compounded monthly over the next 40 years in order to have the lump sum amount in B, which is this part right here. So we're going to use the annuity formula to find that out. So the annuity formula that is future value equals payment 1 plus I NT minus 1 over I. And the numbers for this one, so we're going to plug the this number that we have here, that's going to be our future value. So we plug that in, it's going to be 137,175,412 equals payment, which we don't know yet, so this is what we're looking for. And we're going to go ahead and multiply that times 1 plus I, which in this case is put a 7, because that is the 7% annual interest compounded monthly over 12 because it's monthly, times 12 because every month we're going to save for 40 years because that's how many years we're going to be saving, minus 1, and then we're going to divide all of that by 0.07 over 12 again, which is our I. And then we're going to do the math on this one. So you're going to bring this down because we're going to use this to discover what our payment is going to be. So 1 plus Also, sorry, this is not a part of the equation. This is its own thing. So this is like, it's not on the numerator at all. So 1 plus 0.07 over 12 times, or 12 times 40 minus 1 over 0.07 over 12. So then we're going to get 2,624.81339.8. And that's our number next to PMT. Then we're going to do the same thing we did last time, just reverse. So 2,624.81339.8 is going to come out of this other number that we had, which is our future value for how much we need to have in our retirement to be able to achieve that future value. So we're going to do that really quick. 1371754.12 divided by 2,624.813398. So then this means that our payment is equal to 522.6101,486. So this is how much we need to save every month for 40 years at our 7% annual interest. 522.6, and again we're going to round so that we're going to save this every month for 40 years so that we can get this, so that we can pay out this for the next 20 years that we're retired. So now for the last part, we're going to determine how much total interest we earned over the course of 60 years. And this is the really easy part because it's your paid out minus your paid in. So we're going to take her payments that she was paying in for those 40 years, figure out how much that ended up being, and subtract that from how much she took out during the time that she was retired, and that's going to be how much interest overall that she earned. So that's going to be, so her paid out, or her, her paid out is going to be this 522.62 times 12, because she does it every month, times 40, because that's how long she's saving. So that is $250,857.60. This is her. This is paid in. And then her paid out is the amount that she was taking out. So she needs, every month needs $9,052.97, because that's her future cost of living that we calculated in the beginning. And she's going to need that every month for the 20 years that she is going to be retired. So that's how we determine that one. So then that's going to be 9,052.97 times 12 times 20. We're going to get a big number, 2172712.8. And we're going to subtract her paid out from her paid in. And that's how we're going to find how much interest she earned. So that's going to be 2172712.8 minus 250,857.6 250,857.6. So then her total that she's gonna get so this is how much total interest earned. Over the course of the 60 years. So this is how much she earned after saving for 40 years and being paid out for 20 years. So to kind of cover it up, first we found the future value cost of living by taking her current cost of living, making sure we took account of inflation. Then we used that future cost of living to determine how much that she needed to save by the end of her 40 years of saving to be able to retire with this future cost of living being paid out every month for 20 years of retirement. And we found out how much we needed to pay for 40 years so that at the end of 40 years she could have this much money to then again have this much every month to live comfortably. And then we determined total interest earned after the 60 years. So yeah,